Hi, I'm Tim Howland from Johnson Outdoors Minn Kota. In this video, we will show the diagnosis, testing, repair, or replacement of a control board on a Traxxis style variable speed motor. We'll use this Traxxis 55 as a representative example of a motor that has a control board. Let's first of all diagnose and see if this motor is going to run. We'll connect it to our 12-volt power source here, and we see that it immediately runs full speed with no rotation of the handle required. And so this is a little bit of a dangerous situation because the motor started to run immediately as soon as I connected it to power. So we'll want to start, first of all, up here in the top end where that control board is located. We'll start by removing the 6 screws that hold the cover in place. With the 6 screws removed, we can lift the cover up and off to the side. We'll start by disconnecting the 2 leads that go to the push-to-test battery meter. We'll take a close look and we see the cause for the problem. In this case, what has happened is that the customer has inadvertently or accidentally attempted to stow the handle without having the handle in the off or stow position. As we can see with this particular circuit board, the board is stuck in an on position, and the shank or shaft coming out of the potentiometer is broken off almost flush with the body of the potentiometer itself. Because this is a ribbon style lead on this particular circuit board, we will need to replace the entire circuit board to correct this malfunction. On later models, the ribbon lead has actually been replaced with 3 individual conductors, a white, a black, and red lead. And it is possible to replace just the potentiometer. We'll show how that's done in just a few minutes. However, with this circuit board, as I mentioned previously, we will need to replace the circuit board. We'll start by disconnecting, making sure that we've got power disconnected from our power source. Then we'll disconnect the B- and B+ leads and the motor minus and motor plus leads as well. 4 screws are used to hold this circuit board into the control box. We'll start with these 2 screws at this end. Next, we'll remove the 2 screws that come in from the back side and go into the heat transfer bar on the circuit board. You'll notice that the screws that are used for this purpose are machine screws, as opposed to the thread cutting screws that are used in the other locations. With all of the screws removed, we can now lift the circuit board out of the control box. As mentioned previously, this board has a ribbon lead, so it is not repairable. Compare that to the current style circuit board that has 3 individual conductors, the black, the white, the red leads. We will need to reuse the large fender washer that's on this circuit board, so we'll have to remove that quickly and move it over to the new board assembly. The fender washer is actually used to hold the potentiometer in the control box. We'll install the control board in the control box, and then we'll install our 2 machine screws that come in from the back side and go into the heat transfer bar. It's always a good idea just to turn the screws backwards just a couple turns so that when you start the screw back in again, you're not cutting new threads, but reusing the ones that were cut previously. Always be sure to reference the wiring diagram that's packaged with that control board. We have been known to make pinout changes on circuit boards from time to time, moving the location, for example, of the B- and the motor minus leads. So be sure you consult the wiring diagram that is included with the circuit board so that you can properly rewire that particular circuit board that you've just received. This board we know is the same exact style as the one that was removed, with the only difference being the individual conductors replacing the ribbon lead. So if we've remembered where those leads are connected, we can plug our B- back into the terminal between the heat transfer bar and the relay on the circuit board. Battery positive goes over on this side, and motor minus and motor positive go in these two locations here. Make sure that you tuck the wires back into their proper positions so that they aren't going to be pinched. The cover is reinstalled. So everything looks good there right now. We're ready to slip the control box cover back into place. First of all, we'll have to reattach the push-to-test battery leads. You'll notice that the wires are color-coded as well as the terminals being connection-specific. So it's very difficult to mess this up. And now we need to reinstall our handle assembly as well as the spring detent. You'll notice that the raised surface is going to be towards the handle assembly. So this needs to be installed just like this. That with the handle in the off position, the flat on the potentiometer should be facing up as an aid in reassembly. Now it slips right into place. Make sure that the handle bearings are in position. The handle is in place. And now the cover is ready to be installed. This handle detent spring will actually contact this outer surface. If we can take a look inside here, it'll actually come up right up against this flat surface in the control box cover. So what we have to do is hold the wires down and kind of come in from the back side a little bit and move that forward as we're squeezing it into place. Make a quick look, make sure that we're not pinching any wires, and it's down and in place, and we're ready to install these cover screws. We'll start with the two screws here that are kind of at the midpoint in the control box cover, one on each side, just to kind of hold things in place while we install the other four screws. It helps to maintain some downward pressure on that control box cover. Everything's looking good here. Now what we may want to do at this point, before we install all the rest of the screws, is just to make sure that everything is going to work properly. So let's connect that motor back up to our 12-volt power source. Well, first of all, we realize that the motor is not running when I connect it, which is always a good sign. We should be able to start the motor out at a relatively slow speed. This is in the forward speeds, and we can see that the prop is varying in RPM as we go from 10% to 100% power. Back to the off position, and now we check reverse, and we see that the prop is varying in RPM as we go from off to 100% in reverse as well. So our circuit board replacement has corrected the malfunction. We'll complete the repair by installing the remaining four screws. This completes our circuit board replacement on a Traxxis hand-controlled motor.